Morning, ladies and gentlemen. Welcome here at the group exhibit Hydrogen Fuel Cells Europe at Hanover Fairground 2023. My name is Mona. I'll be the moderator for today in the technical forum. Yes, this is all about technical presentations from our exhibitors. And I would like to say a few words about this year since this is the first slot here in the forum. I welcome all of you to come and have a seat and enjoy the first presentation. We are exhibiting here on Hanover Fairground with 10,000 square meters. We have more than 270 exhibitors this year, lots of new exhibitors and lots of old familiar faces. So I welcome everyone also who's watching online. We are live streaming from this fair. So hello, konnichiwa, ni hao, everyone who's watching worldwide. Please come and have a seat. There are free drinks. We're serving them all for you. There are two lovely ladies walking around serving you with the drinks. So I guess everyone who came here is very interested in the next topic. We will be discussing optimization of power conversion for the large-scale production of green hydrogen. And for that, please welcome with me on stage our first speaker, the Global Business Development Manager from AEG Power Solutions, Mr. Andreas Emmert. Welcome.
Yes, so thank you, Mona, for the introduction, and welcome also from my side to Hannover Messe 2023. So it's a pleasure for me to present to you today the optimization of power conversion for the large-scale production of green hydrogen. So first some words about the AEG Power Solutions. So we at AEG Power Solutions are experts in power electronics, and we design and produce products and systems and solutions to ensure the continuous operation of critical processes in demanding applications such as power generation, transmission and distribution, non-stop industrial processes, rail infrastructure. And when it comes to the energy transition, we provide energy storage systems for on- and off-grid renewables integration, and also power converters and rectifiers for green hydrogen production, our today's topic. So AEG Power Solutions is a company with a global footprint. Together with our 52 service partners, we are present on all continents. We have R&D activities in Europe, in Warstein-Bielicke in Germany, and also in Vitoria in Spain, where we also have our manufacturing capacities, and we also have a manufacturing capacities in Asia, in China and in Singapore. So now coming to the requirements for power supply when it comes to green hydrogen production. So I have here three categories of requirements that you have to take into account when providing power supplies for powering electrolyzers for the production of green hydrogen. So on the left-hand side, you have the grid requirements. Here, the most important figures of merit are the power factor that has to be high, meaning as close as possible to 1 normally. And you also have to have a low total harmonic distortion, THDI. And what is also more and more important is the provision of power dynamics in order to provide to the service demand flexibility to cope with the higher and higher penetration of intermittent renewable energies. On the right-hand side, you have the electrolyzer requirements. So the production of hydrogen is proportional to the current, and in order to produce massive amounts of hydrogen, you need massive currents, normally in the several kiloampere range, and you have to provide power of megawatts, and in the near future, hundreds of megawatts and gigawatts. And in order to drive these electrolyzers from 0 to 100% of the production capacity, you have to provide a large DC voltage window. On top of this, also the DC current quality is key. This is normally measured by the current ripple that has to be low. Otherwise, the efficiency of an electrolyzer might go down, and it is also subject to aging. Of course, you also have to care about functional safety. And at the startup of the electrolyzer, before starting the production of green hydrogen, you have to polarize the electrolyzer and you have to take care about the reverse current. And now, if you want to produce green hydrogen at lowest cost, you have to take into account also economic requirements. First of all, of course, the efficiency that has to be high at all loads, because around about 75% of hydrogen costs are electricity costs. Then also your equipment has to be robust and reliable, otherwise you will spend your time maintaining and repairing the equipment, particularly when it comes to the future gigascale factories. It should be scalable and modular, as we think that we should profit from the smaller megawatt installations today to put this return experience on profit for the future gigawatt factories. And then also, equipment has to be compact, so small footprint to reduce the capex, and finally, easy to install to reduce cost and time on site. And so we at AEG, we are active in this market since 2009, and this allowed us to develop a unique hybrid technology that is combining IGBT and thyristor technology for integrated grid compliance and maximum efficiency, robust and flexibility at all operating conditions. And without going too much into the technical details, you have here on the right-hand side small schematic of our rectifier technology with, on the AC side, a thyristor-based AC-DC rectifier, followed by a full IGBT DC-DC converter. And it's actually this second stage that allows us, on the one hand side, to provide the large voltage window needed by the electrolyzer, and on the other hand, to operate the AC-DC thyristor-based rectifier on its optimal point of operation, meaning at full duty cycle, which is very favorable for the low THDI we can achieve. And as it is a buck converter design, we are able to operate at high voltages and low currents, which is very favorable for the high efficiency. And so we have measured a peak efficiency of 99% peak. I also would like to highlight that the thyristor-based AC-DC converter is robust and protecting the rest of the equipment against power line defaults. And we also have an integrated safety circuit up to seal3. Current ripple below 1%, high power dynamics compatible with a frequency containment reserve market. We have an integrated electrolyzer polarization, reverse current protection, and we are compatible with all electrolyzer technologies. And on the next slide, I would like to give some more details about the modular and scalable design and the easiness of installation. So it's a modular design. One module gives you up to 1.25 megawatt of DC power, and you can put up to 8 modules in parallel, giving you a power output of up to 10 megawatt. So it fits all project sizes, and it comes in different packages. So normally we provide the transformer rectifier unit, and as a function of the project size, this comes in different packages. So on the right-hand side, for the smaller projects, which are most of the projects we see at the moment, our equipment is directly integrated in the electrolyzer plug-and-play container. And when it comes to bigger powers, then our equipment can be fit into a separate plug-and-play outdoor container solution. And for even higher powers, we can provide a plug-and-play skid solution. And of course, we can also integrate our equipment in all other kinds of buildings and future factories. And here you can see now a detailed view of our plug-and-play skid solution, with on the right-hand side the transformer in an outdoor enclosure. On the left-hand side, the cooling system providing the cooling water for our rectifier system. And so now the most important part, the references. So as I said, we are active in this business since 2009, and we have today references with all of the most important electrolyzer OEMs. And one of the references I have selected for you today is a project with Emprise, also known as a Demo for Grid project. And it's actually, Emprise is a supermarket chain in Austria, and they have decided to produce their own green hydrogen to fire their bread bakeries, but also to fuel their delivery trucks. And in this project, we power a Sunfire alkaline electrolyzer of 3.6 megawatt, and we had to deal with extremely severe grid requirements and also grid service requirements. That's why the project is called Demo for Grid, because it's aiming at proving that we can provide frequency containment reserve services to the grid. Second project is a project in Southern America, in French Guiana. It's actually the largest renewable baseload power plant in the world. Here, the aim is to cope with the intermittency of solar power produced by the photovoltaic plant by combining battery storage, electrolyzers, hydrogen storage, and fuel cells. And our customer in this project is Siemens Energy, who is the integrator of the H2 system. And here we power McPhy alkaline electrolyzers with an installed capacity of 16 megawatt. Then on the left side, a rather small project, but still very interesting, because here the aim is to produce green hydrogen, to produce green steel in Sweden. And here we power a Hydrogen Pro alkaline electrolyzer. Then in the middle, you can see one of the many projects we have that are about green hydrogen for mobility application. So in this case, a municipality wanted to produce their own green hydrogen to inject it into the conventional grid. So we talk about blending, but also and foremost to power the public buses and trucks. And then on the right-hand side, one of our oldest projects from 2011, where already at that time it was the idea to overcome the intermittency of wind power by producing, storing, and re-electrifying hydrogen. And with this, I would like to conclude and to invite you to come to our booth F11 in this hall to meet our experts and ask all the questions you might have after this very short presentation. Thank you very much.
Thank you very much. That was very interesting, I think. And if you do want to continue this chat, you already said that you are happy to welcome that at your booth F15. Thank you so much. F11, sorry. F11, my bad, F11. So thank you, Mr. Andreas Emmert.